Good people, Sanbunan, Makebalo. Today we are doing this video for grade 11 paper of November 2019. We'll be doing some revision for a probability. So yeah, let's get into it. Here in this question is saying event A and B it's given, and event A it's 0, probability of event A 0.48 and B 0.26. So they're asking us to find the probability of A and B if A and B are independent. Now probability of A and B, so if they are independent, it's going to be probability of A times the probability of B, which is going to be equals to 0.48 times 0.28, which is going to give us 0.1248. This is the probability of A and B. Now, probability of A or B is going to be probability of A or B. Now, if A and B are mutually exclusive, so if they are mutually exclusive, probability of A plus the probability of B, which is going to be 0.48 plus 0.26, which is going to give us 0.74. This is the first part of probability. Now, going to this one, they are saying a survey was conducted among 350 grade 11 learners to establish which snack they prefer to eat while they watch television. The results were summarized in the Venn diagram below. However, some information is missing. So I'm having this Venn diagram of chips and nuts and dry fruit. So 30 here it's for the dry fruit only. 25 here is for nuts only. And 41 here is for chips only. 5 is for chips and nuts. 6 is for nuts and dry fruit. And 10 here is for chips and dry fruit. And X that is here is for everyone, is for chips, nuts, and dry fruit. And Y that is outside here, it's for neither. So this Y doesn't take either of these, doesn't take chips, doesn't take nut, doesn't take dry fruit, doesn't take anything. It has to do with these three snacks that are there. Now 9.2.1 is saying if 29 learners prefer to at least take two types of a snack, calculate the value of X and Y. Now, any two, so if they're saying any two, meaning it's going to be 10 plus 6 plus X, so 5, which is going to be 29. So these 5 and then these 6, then these 5 and then also these X, all of that equals to 29. So calculating that 5, 6, 10, 6, and 5 is going to give me 21 plus X is equals to 29, and my X is going to be 8. Now, 9.2, oh, finding Y, sorry. Now, finding Y is going to be all of these values also while there is going to be equals to 130 because those are the number of learners that are in this survey. So it's going to be 41 plus 10 plus 30 plus 6 plus 8 plus 5 plus 25 plus Y, which is equals to 130. Now adding all these numbers gonna give me 125 plus Y is equals to 130, and then Y to the other side is gonna be 130 minus 20, 125, which is gonna give me 5. So that is a value of y. Now 9.2.2, they're saying let's determine the probability that a learner who does not eat nuts will either have another snack or no snack while watching a television. Now, probability of no nuts snack or no snack at all is going to be equals to, now for one, for no nuts is 41 of them plus 10 plus 30, which is equals to 130, plus now no snack at all, it's 5 of them divided by 130, which is the answer. From there it's going to be 43 all over 65. That's the probability there. Now 9.3, a group of 200 tourists visited the same restaurant on two consecutive events. On both evenings, the tourists could either choose beef or chicken for their main meal. The manager observed that 35%, 35%, hey, sorry about that, 35, why is that writing now, this thing? Oh, yeah, sorry guys. 35% of the tourists choose beef on the first evening. So 35% choose beef on the first evening. And then 75% of them choose chicken on the second evening. Now, what is very important here, on the first evening, there's 35 that choose beef. Now, on that same first evening, how many of them that choose chicken? So, them that choose chicken is going to be hundreds minus this 35 to get the one who choose chicken on the first evening. And also here, 75 70 sorry of them choose chicken on the second. So how do we get them, those that they choose beef on the second evening? Again, it's gonna be 100 minus this 70 to get the one who choose beef on the second evening, which is gonna help us in terms of doing this tree diagram here. So 9.3.1, they're saying draw the tree diagram. Now this is going to be my first evening. So in my first evening, I have this 35% of the tourists that choose beef. So choose beef. Now, still the first evening, obviously, they are going to be the one who's gonna choose chicken. So if I have 0.35, so I'm gonna write it in decimal places. They choose beef. Then how many of them they choose chicken on the first evening? So it's going to be 100 minus 35, which is going to be 0.65 in decimal places. Now, this is my first evening. Now, it's the second evening, we're going to have beef and chicken also. Second evening, beef and chicken. So now, on the second evening, they're telling me that 70% choose chicken. So if 70% choose chicken, it's going to be 0.7. So how many of them that choose beef? Again, it's 100 minus 70, which is going to be 30, and then that 30 in decimal places is 0.3. Same thing here, it's just going to be 0.3 and then 0.7. So from here, these are the beef, and this is beef and chicken, and this is chicken and beef, and then here is chicken and chicken. So this is my Venn diagram there. Now in 9.3.2, they're saying calculate the number of tourists who choose the same meal on both occasions. Now same meal, beef and beef, chicken and chicken. So how do we do that? Now the probability of beef and beef plus the probability of chicken and chicken, which is going to be 0.35 times 0.3 plus 0.65 times 0.7, which is going to give me the answer of 0.56. So this is a probability of the tourists who choose the same meal on the both evenings. Now 9.3.3, they're saying show that more tourists opted not to choose their choice of the main meal during their two visits on the restaurant. Now, what is very important here is to find the number of clients who choose a different meal. Calculate the number. Oh, I'm not done with this question. Thank you so much. The number of this question, I'm not done here because I'm calculating the number of tourists. Now, these, after finding these, we're going to say 5.56 times 200 because those are the 200 tourists, then which is going to give me 112 clients. So these are the clients that I was calculating that chose the same meal on the boat evening. Now 9.3.3 show that more tourists opted not to change their choice of the main course during their two visits on this restaurant. So first thing here, I need to calculate the number of clients who chose the different meal. So I'm going to calculate the number of clients who chose different meal. So which is one, remember I have 200 clients, so this is 200 clients minus, remember here, these are the clients who chose the same meal. So if I can minus the one who chose the same meal, I'm going to get the one who chose different meal. So which is going to give me 88 clients. So if I have 88 clients who chose different meal, now the question is saying show that do not change. So I can see now, therefore, more clients prefer to make the same choice. So from here, I can say now, from conclusion, more clients preferred to make the same choice of the meal. The same choice because in terms of numbers, 112 they chose the same meal and 88 time chose the different meal. So numbers don't lie. Thank you so much guys for watching. Makebalo.